not using class, it can communicate on its own. Got
Yes,
it.
yes.
Thank you, sir.
So any other questions? Any other questions, guys? Okay, so if no questions, okay, I'll go to my class. Okay, so I'm sharing my screen, guys. Okay, so can you see my screen? So yesterday we were talking
Yes,
about
sir.
this one, right? Okay, so again, okay, this is one-time activity. Okay, so I will say this is the one. Okay, sir. Huh? Is it fine?
Okay, sir. Yeah, got it. Yeah.
Okay, so here also I what it is. Okay. Okay. Clear, sir.
Yes, sir.
Okay, so we did this one. Okay, so now your cluster is ready with the two name nodes. Okay. So otherwise, okay, what I will do, I will stop everything and I'll start everything at once. Stop entire cluster. Huh? Okay. Now I'll do one thing. Okay, I'll stop entire cluster first. Okay. I'll stop entire cluster first. Okay. And okay, I'm starting entire cluster. Okay, I'm starting entire cluster here. Okay. Now if you see, you have 3 general nodes. Okay, and you have 2 name nodes, and you have 3 data nodes and 1 edge node. Okay. So normally what will happen is when you start your cluster, okay, what will be the status of both the name nodes? What is the state of both the name nodes? Normally, okay, see any name node is started or restarted. Okay, so by default the status will be standby. Okay, by default the status will be standby. Okay, so now if any okay, if both the name nodes are standby, okay, do you think okay the user commands will work? Can user okay, execute their command if both are in standby?
No, sir.
No, sir.
Okay, so you take user. Okay, so SDFS, DFS, -ls root. So it is getting error saying that okay, it is unable to find the active name node. That is the reason it is retry. So here, see everywhere it is operation read is not supported in standby mode. Okay, so here also it is saying that okay, not possible in standby mode. Okay, so this is what the error we are getting. Okay, so what we need to do as a Hadoop admin, whenever you restart your both the name nodes, you need to check okay, check the status and at least make okay, one as active. Understand? Make one as active. Okay, how to make this as active? Transition to active. Okay, now if you see the status of both the name nodes, okay, now you have both the okay, one is an active state, another one is standby state. Will you agree with me? One is active state, another one is standby state. Okay, so this is the current status. So if active name node is there, then obviously my command will work. Yes. Okay. So now okay, when Alan run a command, okay, is he facing issue now? He is not facing an issue. He is getting the output. Okay. So here the problem is that okay, what in case okay now first name node is in active. Suddenly stop the first name node. Okay. Now if you see the status, okay. Now first name node is down and second name node status is standby. Okay. Again, if you run this command, since there are no active name nodes, okay, this is the problem. Understand? Okay. So immediately whenever okay, name node is down, okay, so either Hadoop admin okay, will continuously checking this name node status, or okay, whenever developers are facing an issue, developers will contact Hadoop admin and Hadoop admin immediately will change the status to active. Understand? Okay. He is saying this second name node status to active. Now, if you see the second name node status active, yes, okay. Now, okay, developers will be able to run their commands. Understand? Okay. If active name node is not there, or if any node name node is not in active state, okay. So obviously, developers cannot run their commands from edge node. Okay, not only from edge node, from any node actually, but okay, developers are the ones. Okay, so developers or admins cannot run any command from any node. Clear? Or any questions? Clear? Or any questions, guys? Okay. So now, okay, what I will do? So I will start the first name node. If you start the first name node, what is the status of first name node? Standby. Okay. Second name node is inactive. Okay. Okay. Now one is active and one is standby. Okay. So I want to interchange the status of both. Okay. Both with one command. Can I interchange? Okay. So there's a command which is called as failover. Okay. Now if you see first, okay, first name node status is standby. Okay. 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 Now you see. Okay. So standby active. So now what is the command we used here? What is the command I used here? Failover. Failover from where to where? Okay, S3N2 to S3N1. Okay. So when you use failover command, what will happen automatically? Okay. S3N1 will active. Whatever is there in the last, okay, that one will become active. And whatever is there in the first, okay, that will become standby. Okay. Now you see the status of both the name nodes. Now, okay, name node 1. Okay, earlier name node 1 was S3N1 was standby. S3N2 was active. Okay, after failover command, okay, S3N1 has become active and S3N2 has become standby. Understood? Understood? Are any questions?
So this is another way of bringing live to like bringing like to make active.
Okay, this failover command will
node.
work. Okay, this failover command will work only if both the name nodes are up and running. Got it?
Okay,
if you want to interchange the status of both the name nodes, interchange the status means okay, both should be up and running. Then only failover will work. Otherwise, no. Got my point?
Sir, if one name node is suddenly breakdown, okay, is it switched to the second one automatically?
It is not switching, right? Is it switching here? I'm showing you practically, right? Is it switching?
No, that's what I'm asking.
It's not switching. Possible. It's not switching actually. Okay, so whenever there is an issue, so what admin is doing? What admin is doing?
He is making other one active manually.
He is making other one as active manually. Got it, guys?
Yeah, if it take time, the admin will take time to.
Suppose okay, let us take this scenario. Okay, let's say night 12 o'clock. Okay, first name node was down. Okay, so admins will come morning 9 o'clock. Okay, it means okay, night 12 o'clock to morning 9 o'clock, nobody can run any command. Understand?
Yes, sir, that's what I'm asking.
Yeah, nobody can run any command. Okay, so this is what the version they released. Is it a good version or bad version? Somewhat good, but okay, there are many manual interventions. Correct or not?
Yes, sir.
So nice. Vipin sir.
Yes, sir. Good. I am good. Yeah. Got it. Yeah. Thank you.
Okay. Yeah. So this is what the version they released in Hadoop 2x, and they told like okay, yes, okay, we release the second version with 2 name nodes. If one name node is down, also Hadoop admin will make other name node is active, so that okay, the work will continue. Okay, and okay, there is no need to copy the metadata manually because both the name nodes will store the metadata in a common place. Okay, that is the reason. So if any one name node is down or corrupted, you no need to copy the metadata to any place. Only thing is that when the name node is completely burnt out, just attach a new name node. Okay, just execute bootstrap standby command and start your name node. So it's with the 2 steps. Okay, you can bring the new name node up and running. Okay, so that's the advantage. Okay, so out of 3 issues, okay, so 2 issues are solved. Okay, with the help of Hadoop DX architecture, but only one issue which is annoying us is manually making second name node is active. Correct or not? If any active name node is down, manually making standby as active is a problematic task for us. Okay, as I told you, okay, night 12 o'clock suddenly active name node was down. Okay, So admins will come in the morning 9 o'clock or morning 6 o'clock. Till morning 6 o'clock, our cluster will be in a down state only. Even though you have a other name node, but other name node is standby. If it is a standby, it cannot help users or developers. Correct or not? Correct or not, guys?
Yes,
Okay.
sir. Good.
Yes, sir.
Sir,
Tell me, sir. Yeah, please go ahead. No questions? Okay, fine. So next one is manual checkpoint. Okay, when you have two name nodes, how to perform the manual checkpoint? Okay, so this is how you'll be performing the manual checkpoint. What is the command? Okay, so when you say manual checkpoint means safe mode enter. When you say safe mode enter, both the name nodes will enter into safe mode 181 and 182, and both the name nodes will perform their checkpoint. Okay, and both name nodes will leave the safe mode. Okay, so it means okay, when checkpoint is happening, it's happening for both. Okay, so and if you want to perform for one name node, you can perform okay checkpoint for one name node like this. And then okay, it is performing name node for only one name node. Safe mode is on. Save namespace is successful. Safe mode is off. Okay, so this is how checkpoint will be done. Okay, but normally if you have two name nodes, okay, whichever is playing a role of standby, that one will be taking care of. Checkpointing process. Okay, and whichever is active, that will be taking care of user requests. Are you clear here? Are you clear here, guys? Okay.
Yes, sir.
So with the help of this one, okay. So the first point, okay. So this point is solved. This problem is solved. Limitation of single name node. Okay. So now name node is not single point of failure. Now we have two name nodes. If active name node is down, you have a standby name node who can become active and okay can help okay the users in running their commands. Okay. So now name node is not single point of failure. First thing. Second thing is that okay, chance of losing metadata if checkpoint doesn't occur. Okay. So where is the chance here? Okay, is there any chance? Because okay, so both the name nodes are writing their data into both the name nodes are writing their data into or their metadata edits into a common place. So and again we have three common places. It's not one common place. Yes or no? Even okay, one common place gone also, you still have two more common places where you can get your data. Yes or no? Okay, so that's the reason. Okay, so there is second problem also not there in Hadoop 2x. Okay, and metadata files needs to be copied manually in case of primary name node crash. Okay, even this problem also not there. Okay, metadata files okay are already there in a common place, so no need to worry about the third point also. Okay, so these are the limitations raised by customers again in 1x. Okay, so these limitations are solved, are taken care in Hadoop 2x. But okay, while they were taking care of these limitations, they had another limitation. They got another limitation. Okay, so what are the challenges with name node availability? Okay, so first one, how to maintain common copy of edits when we have multiple name nodes? That's the first challenge. Okay, so what in case if common copy of edits is lost? Okay, so these are the two questions. Okay, so for this one we introduced a solution like additional mechanism of quorum general manager. A group of general nodes is required to maintain multiple copies of common edits. Okay, so if you have two name nodes, how to maintain the common copy of edits? Okay, and second thing is that what in case if the common copy is down? Okay, so to answer these 2 points, okay, so we have quorum general manager, okay, which can maintain, okay, so where you will have minimum of 3 general nodes, and okay, you can, okay, your common edits will be maintained in multiple places, so that even one place is gone also, okay, you still have edits from 2 different places. So there is no problem to lose, or there is no need to worry in losing okay, what is it? Common edits. Okay, so the second challenge here. Okay. First challenge is completely taken by quorum general manager. Okay. What is the second challenge here? When is the second challenge? When both the name nodes are in standby state, which name node should be selected as active? You got my point, guys? Are you getting my point? Okay. So normally, when you start both the name nodes, okay, what is the status of both the name nodes?
Standby.
Standby. Okay. So when you start, okay, so both the name nodes, okay, okay, stop now. Okay, let me stop name node, and okay, start name node. Okay. So now in this scenario, I restarted both the name nodes. Okay. Now if I see the status of both will be in standby. Okay. Now the first question is that, okay, when both are in standby, okay, who should be made as active? Who should be made as active?
Admin.
No. Okay. Okay. Which name node should be made as active? Admin will do, but okay, which name node? I can make any name node as active, right? First of all.
Yes, sir.
Yes, right. Okay, I can make any name node as active. Okay, so can I make first one as active? So if I make first one as active, okay, first one, okay, may think that okay, our second one may feel bad, right? Huh? Of course, it is a machine. Okay, it doesn't have feelings. Otherwise, okay, if it can express feelings, it will feel bad. Why? I also have chance to become active. Why did you make okay S3 N1 also only active? Why not me? Correct or not? Okay. So, and again, okay, so one more thing, okay. So if S3 N1 has become active, then okay, all the user commands should be taken care by S3 N1. Correct or not? Correct or not, guys? Okay. But what is the work of S3 N2? S3 N2 will be just okay, every 6 hours it will perform checkpoint and sit ideally. Okay, it means okay. So this will be enjoying nicely, and okay, this will have more work. Correct or not? Again, okay, there's a feeling. Okay, so now we should not take this option like okay, who should become active and who should become standby. Okay, that should happen automatically. First thing, got it, guys? When you have two standbys, okay, who should become active and who should become standby should be done automatically. First thing, okay. Second thing, okay. What is the second thing here? Okay, who will change the state of name node, standby name node to active when active name node is down? Okay. As of now, what is happening? Active name node is down. Okay. So what about the standby name node? Is it automatically becoming active? No, it is not becoming active. Okay. So you have to, as a Hadoop admin, you need to run a command to make it active. Correct or not? Then only it will become active. Otherwise, no. Will you agree with me?
Yes.
Right? Okay. Yeah. Okay. So in this scenario, okay, these are the again two problems. Okay, when you go for two name nodes. Okay. So when both are in standby, who will become active is the first question. Okay. Second question is that okay. Second problem is that okay, if active is down, who will make standby as active automatically? Okay. So these are the two problems okay, which we are seeing. Okay. So for this problem, okay, what is the solution? Additional mechanism which is zookeeper required to automate this process. Okay. So now we are introducing one more character okay in our cluster. Okay. Who is this one more character? Zookeeper. Okay. So we'll see what is zookeeper. Okay. So okay. So guys, okay, understood what is quorum general manager? A group of general nodes. Okay. So what is the use of general node, guys? What is the use of general node?
Edits.
Huh?
To write edits.
Common copy of edits.
Common copy of edit.
Okay. So general nodes are the ones okay, who will maintain common copy of edits from both the name nodes. Correct or not? Okay. So here, okay, so why we are going for okay multiple edit logs or multiple copies of edit log? Because okay, if I have only one common copy, that one common copy is lost, okay, I may be in problem. There are chances of data loss. Okay, if edits are lost, okay, there are chances of data loss. Okay, so to avoid this one, we are going with the multiple, okay, multiple journal nodes. Okay, now, okay, so this is the architecture they have released, guys. Okay, so we have 3 journal nodes, 2 name nodes, one is active, another one is standby, and multiple data nodes. Okay, now if you have multiple name nodes, okay, each data node will be sending heartbeat to both the name nodes. Understand? Here, heartbeat, block report, everything will be sent to active name node. At the same time, it will be sent to standby name node also. Understood? Understood or not, guys? Or any questions? Okay. This is the Hadoop TX architecture they released. Okay, but the architecture is whatever the architecture they released is good, but unfortunately, they started with a new problem of automatic collection of name nodes, active name node, and okay, so automatically making standby is active if active is down. So these are the 2 new challenges that they face. So to avoid that one, they are coming up with a concept of Zookeeper. Now, what is Zookeeper here? So let us understand what is Zookeeper. Okay, so guys, okay, Zookeeper is a third-party tool. It is not part of Hadoop. Okay, again, it is a supporting service. Okay, for name node, supporting service for name node. So to help name node in becoming okay active and standby. Got my point, guys? Got my point. Okay, so it is not a part of okay.
Venkat, just a general question on this architecture. So ideally, when one is active, the other one is standby. Ideally, active will only write edits in the journal node. Yes.
Only active will write the edits into journal nodes. Yes.
Okay. Got it. Yeah.
Yes. Okay.
So other one is only doing checkpointing.
That's it. Okay. So what other one will be doing? Other one will be contacting journal nodes, and okay, whatever the new edits done by this active name node, okay, it will take that, okay, and perform checkpoint and send a copy here.
Okay, send a copy here, and then or is that FS image will be replaced? The FS image inactive. Yeah.
Yes.
Okay. Got it. Thank you.
Yeah. Okay. So
but here we are writing only edit logs. Yes, we are not writing the FS image. Means active name node is not writing FS image. Correct?
No, see, first of all, okay, even okay in Hadoop 1x also, okay, is name node directly written into FS image? Is name node directly written into FS image? No, right? First it will write into edit log only, right? From there, okay.
Correct.
Every 1 hour, okay, the edits content will be merged with FS image.
But here thing is it is not contacting name node. Yes, for FS image. How will it merge?
Yes.
That is
Yes.
Yeah.
Okay. So when I say Zookeeper is a highly available, highly reliable, and fault-tolerant coordination service for distributed application. Okay, it's a fault-tolerant coordination service for distributed application. It's a coordination service. It's not a main service, guys. It's a supporting service for both the name nodes. Okay. So now we know the problem. Okay, what is the first problem? Okay, so when we start, okay, which name node should be active? Okay, if we start both the nodes, this is the first question. Yes or no? Yes or no, guys? Okay. So now, okay, so our idea is to bring Zookeeper here. Okay, Zookeeper service here. Okay, so now, so let us understand. Okay, later. Okay, like where to install Zookeeper and all. But okay, our idea is to bring Zookeeper service here. Correct or not? Okay. So now, and again, okay, using this Zookeeper service, okay, we need to manage. Okay, we need to manage both the name nodes. Okay. So now here, okay, we have name node 1. Okay. Here we have name node 2. Two name nodes we have. We have two name nodes, and okay, we have one zookeeper. Okay. So now how this zookeeper will, okay, now the question, okay, how this zookeeper will decide, okay, who should be active and who should be standby. Just 1 second.
Sir, we are not able to hear you.
Oh, sorry, sir. Okay. Sorry. I was talking on mute. Okay. So now we have two name nodes. Okay. I started both the name nodes. Both are in standby. Okay. Now we are bringing zookeeper to select any one as active. Okay. Now the question is that, okay, which name node it will select, okay, as active in this scenario. Tell me, guys.
The one which was active before, is it possible?
Okay. How zookeeper knows that which one was active earlier?
Maybe it gets some kind of heartbeat.
So, okay, let's say it is the first time I'm starting. Okay, no earlier stages and all. First time I'm starting. In that case, sir, very simple, sir. There are two people, sir. How will you decide? Okay, he is 1 and he is 2. There are two students in the class. Okay, how will I decide? Okay, he is the first student, he is the second student.
Who will come first?
Who will come first? Yes or no?
Roll number.
Okay. No. Okay, this is the first student today in the class. Okay, is it based on roll number? Maybe roll number 1 may come late, right?
Yes.
Okay. So here, okay. So let's say, okay, you have a team. Okay. So how your manager will decide, okay, who has come first today? Who is the first employee today? Who is second employee today?
Attendance.
Attendance. Okay. You're swiping otherwise. Yes or no? Otherwise, you are swiping actually. Okay. So you will swipe your card. Okay. So that, okay. So whoever swipe the card first, okay, that guy will be the first employee. Okay. In today. Will you agree with me? Okay. It is the same case even for name nodes also, guys. Okay. It is the same case even for name nodes also. Okay. Now, okay. See, whenever, okay, name nodes are started, okay. So let name node send heartbeat to zookeeper. Hey, I joined. Okay. Or I start. Okay. I'm ready. Okay. Let's say name node 1 has sent the heartbeat at, okay, 7:45. 7:45. Okay. 0:1 second. Understand, sir? Okay. Name node 2 has sent a heartbeat like, okay, 0:2 second. Now tell me who came first today?
Name node 1.
Huh?
Name node 1.
Based on this time, based on this heartbeat. Otherwise, okay, I'll put it here. So to zookeeper, okay, name node 1 heartbeat has come, okay, at 7:45:01 AM. Okay. So name node 2 heartbeat has come, okay, at, okay, 1 AM. Okay. This is the time, okay, it has come. Okay. Now tell me, okay, who should become active and who should become standby?
One is
Who
active.
came to zookeeper first?
One is active.
Whoever comes to zookeeper first, okay, so that one will be taken as first name node. Correct? So whoever comes first, I'll make that one as active. Problem solved, right?
Yes, sir.
Yes or no? So there is no what to say? Okay, injustice here. Okay, let's say okay. Tomorrow I'm starting both the name nodes. Tomorrow, name node to send heartbeat to Zookeeper first. There are chances, right? If tomorrow, if you restart both the name nodes, if name node 2 send the heartbeat to Zookeeper first, then okay, name node 2 will become active. Understand? So here we are following the justice. First come, first serve. Okay. Whoever's okay. So what Zookeeper is saying that okay, hey, I will sit here. Okay. So as soon as you start, okay, you send me heartbeat. Okay. Whoever send heartbeat to me first, I will make that guy active. Are you clear?
Sir,
Ah.
what if both the name nodes will send the heartbeat at the same time?
But at least okay, so at least okay, microseconds gap, nanoseconds gap.
Okay.
Huh?
Okay, sir.
Milliseconds, microseconds, or nanoseconds gap.
Okay, sir.
Yes or no?
Yes, yes.
Yeah, there are chances, sir. Okay, definitely there will be some gap. Okay, so based on that time, okay, so it will decide. Okay, so now, so if this is the status, okay, so who will become active now? Zookeeper will change this status to active. Okay, and okay, it will keep this as standby only. Or not? This is the first scenario, sir. Okay, and I'll talk about the second scenario. Okay. Let's say Zookeeper, okay, okay, now tell me in this scenario, name node 1 has come at 7:45 3 a.m. Okay. Name node 2 has come at 7:45 2 a.m. Okay. Now tell me who will become active and who will become standby in this scenario.
Name node 2.
Name node 2 will become active. Okay. This will become active. Obviously, this will be in standby state only. Okay. So now our first problem is solved or not?
Yes, sir.
First problem is solved. Okay. With the help of first come, first serve. Okay. So whoever send heartbeat to Zookeeper, that guy will become active, and whoever okay send the heartbeat okay later, okay, that guy will become standby. Okay. This is the first point. Okay. Now the question is that okay, now the question. Okay. So is name node depending on Zookeeper? Okay. Okay. So okay, fine. Okay. So is name node is a dependent software for Zookeeper? Okay. Zookeeper is a dependent software for name node.
Zookeeper is dependent.
Zookeeper is a dependent.
Yeah, Zookeeper is a dependent software. Okay. See, without Zookeeper also name node was able to run. Yes or no? In Hadoop 1x architecture or in 2x initial architecture, also, without okay, Zookeeper also name node was working. Correct or not?
Yes, sir.
Okay. So it means okay, name node 1 is not a dependent software. Okay, dependent software. Okay, so service Zookeeper is a dependent service. Zookeeper is depending on name node. Okay. Zookeeper is a supporting service for name node 1. Correct? Correct or not? Okay.
Yes,
So
sir.
when is the support and the name node is a master service. Obviously, name node is a master service. Okay. Data node is a worker service. Okay. General node is a supporting service. Okay. Zookeeper is a supporting service. Okay. So, do you think name node will send heartbeat to Zookeeper? That is a master node. So normally, sir, normally you take your officer, okay? You and your manager, okay? So early morning, okay? So now offices are opening slowly, right? So it's early morning, okay? Let's say time is morning 9 o'clock, okay? And you and your manager both came to office at the same time. Normally, who will wish first? You will wish your manager, or okay, your manager wish you first. Let's say your manager is a bit arrogant, actually, bit attitude person. Who will wish?
We will wish first.
Normally, employee will wish a manager. Yes or no? Okay. So manager will always will, hey, I'm superior to this guy. Okay, so why should I wish first? Yes or no? Okay. Obviously, yes. Okay. If you wish, okay, yes, okay, he will also wish. That's the second story. But normally, okay, so any manager will expect okay their employee to wish first. Okay, and okay, that's how it works also. Okay, see, when I see my manager first, okay, even if he say good morning or not, okay, I will say, hey, good morning. Then he will say, okay, good morning. Okay, so it works in that way. Okay, any person, it works in the, I mean, in a generic example, it works like that only. Okay, but here also, here, okay, Namenode is kind of a manager, Zookeeper is kind of a supporting software kind of employee. Okay, now is it fine? Okay, is it fine for Namenode to send a heartbeat to Zookeeper? Sending heartbeat means going and saying hi. Okay, no. Okay, so normally any master service will not send heartbeat to Zookeeper. Okay, so if heartbeat is not sent to Zookeeper, then okay, how Zookeeper will understand okay who has come first and who has come second? Do you think okay, Zookeeper will send heartbeat to Namenodes?
No.
So Zookeeper is saying that okay, hey, I am the decider. Who should be active and who should be standby? I am the decider. Okay, so you should send me heartbeat. But okay, what Namenodes are telling, hey, we are the master services in the entire cluster. Okay, why should we send heartbeat to you? So there is a war between these two people. Okay, so to avoid this one, okay, in the next architecture, what they have done, what Hadoop people have done, okay, they got a new service here. Okay, so Zookeeper failover controller.
Sir, Zookeeper has been introduced in 3.x, right? Concept
2.x.
2.x itself. Okay.
Understand, sir? Okay, you try to understand what they have done. What they have done. So they introduced okay. So Namenode will not send okay heartbeat to Zookeeper. So they made it like this, sir. Now the problem solved, right? Now the problem solved or not, guys? What is happening here? Is Namenode sending heartbeat to Zookeeper directly?
No, sir.
No, sir.
Okay. Who is sending heartbeat to whom?
Zookeeper failure controller sending heartbeat to Namenode.
Exactly, sir. Okay. So Zookeeper failover controller is the one, okay, who is collecting the status of their Namenode, okay, and sending it to Zookeeper. Understood? Understood, guys?
Yes, sir.
Okay.
Yes, sir.
So here they introduced okay a kind of PA for Namenode. They introduced a kind of PA for Namenode. Okay. Again, okay. So failover controller is a supporting software for Namenode or not?
Yes, sir.
Yes, sir.
Is it a main software, main service or a supporting service?
Supporting.
Supporting, sir.
Supporting service. Okay. So guys, you need to understand, okay. So what are the master services? Master service. Okay. Worker service. Okay. Supporting service. Service. Okay. So in the cluster, in Hadoop cluster, okay, master service is Namenode. Okay. Worker services, Datanode. Okay. And what are the supporting services? Okay. So general node. General node. Okay. So to whom it will support? Yes or no? Yes or no, guys? What general node will do? It will help Namenodes. Okay. Okay, it will help name nodes to maintain the common copy of edits. Okay. Zookeeper. So, no. Zookeeper also help and name nodes. Okay, in deciding who should be active and who should be standby. Okay, now okay, FC. Okay, failover controller. Okay, this is also help name nodes. No. Here, yes, okay. So these are the master services, these are the worker services, and these are the supporting services. Okay, so normally all the supporting services will be helping master services. Understood? Okay, so here, see, since this guy is a name node is a master service will never send any heartbeat to supporting service. Okay, so but here, okay, Zookeeper is kind of a decider who should be active and who should be standby. Okay, so Zookeeper cannot go to name node, both the name nodes. That is the reason they introduced one PA for name node. Okay, what this PA will do? PA will collect the status of name node 1 and send it to Zookeeper. Understood? Okay, so now, okay, so Zookeeper failover controller 1 will send a heartbeat of name node 1 to Zookeeper. Okay, Zookeeper failover controller 2 will send a heartbeat of name node 2 to Zookeeper. Okay, so now, okay, so here even the ZKFC is going, but okay, end of the health report is for name node. Okay, so here, okay, now in this scenario, who will become active and who will become standby? Tell me guys.
2 is active.
One will become active.
2 will become active and okay, and okay, 1 is okay standby. Okay.
Standby.
So now this is the situation. Okay. Now the question is that okay. Now the question, suppose okay, if active name node is down, that's the next question. What will happen if active name node is down? What will happen?
Zookeeper knows node 2 is down.
Okay. So,
failover controller will
failover controller will send this information to Zookeeper, saying that okay, hey Zookeeper, our boss is dead, is not running at all. Yes or no? Yes or no, sir?
Yes, sir. Yes.
Yes, sir.
Okay, guys. Okay, so before going to this one, okay, so now the question, okay, so this architecture is fine now. This is easy to decide okay, who should become active and who should become standby.
Yeah, yes, sir.
Yes,
Okay.
sir.
Okay. Now these are all name nodes. Both name nodes are started. Both failover controllers are started. But okay, Zookeeper was down, sir, at that time. What will happen? Huh? You have only one Zookeeper, right?
Yes, sir.
So due to some issue, that one Zookeeper service is down. Okay, that one Zookeeper is not running. Okay. Now the question is that okay, both the name nodes are standby. Who will make okay name node as active?
Admin.
Huh?
Admin, unless we have available Zookeeper.
So in this scenario, who has to make it active? When Zookeeper is not there, obviously that will come to again okay, manual work. Okay, should be done by Hadoop admin. Will you agree with me? Huh?
Yes, sir.
Yes, sir.
Okay, so that's a manual work and should be done by Hadoop admin. Okay, this is a problem. Okay, so what to do now? What to do?
More Zookeeper services.
Can we get one more Zookeeper also?
Yeah.
Huh?
Wait.
Okay.
Better to know.
Now I'll get one more Zookeeper here. Okay, this is the next scenario. Okay. So now I'll get one more Zookeeper. This is one more Zookeeper I got. Okay. So now I'm making Zookeeper 1. Okay. Zookeeper 2. Okay. Now tell me, when I have 2 Zookeepers, okay, who will take the decision? Who will take the decision? Okay, the heartbeat should go to which Zookeeper? So the heartbeat of failover controller, okay, name node 1. Okay, so will be sent by failover controller. In the previous example, I have only one zookeeper. Obviously, failover controller is sending, both failover controllers are sending the heartbeat to zookeeper. Okay, but now I have two zookeepers. Now the question is that okay, to whom I need to send? Tell me. To whom I need to send, sir?
To both.
Huh?
To both.
Obviously both. Yes or no? Okay, obviously both. Otherwise, okay. So zookeeper will feel, other zookeeper will feel bad, right? Yes or no? So failover controller will send heartbeat to both. Understood? Or any questions? Yeah.
We'll also talk about where the zookeeper services reside, right?
We will discuss, sir. While doing the practicals, okay, we'll decide. Okay, I'll show you. Is it fine now? Is it is it fine or not? So your control is the one who is sending the heartbeat to both the name nodes. Okay, sorry, both the zookeepers. Correct or not? Sir, okay, here okay, we had only one zookeeper, then no confusion. So both failover controllers are sending heartbeat to that one zookeeper. That one zookeeper only deciding everything. Yes or no? Yes or no, guys? Okay. But here the problem is that okay, what in case if the zookeeper service is down? Okay. So to overcome this issue, what we are doing? Okay, we are going with the two zookeepers. Okay. We are going with the two zookeepers. Okay. Now zookeeper 1, zookeeper 2. Okay. Now, okay, since we have both the zookeepers, okay, so failover controllers are sending heartbeat to both the zookeepers at a time. Okay. When both the zookeepers are receiving heartbeat, they are the people who should decide who should be active and who should be standby. Correct or not? Correct or not, guys? Now, will both together will decide or only one will decide? Here. Sir, what is the confusion? See, I have two zookeepers. Okay. Failover controllers are sending heartbeat to both the zookeepers. So now, both the zookeepers together okay, should decide who should be active and who should be standby. Correct?
Yes.
Yeah, yes, sir.
Correct or not? Okay. Now, okay, let us see the scenario 1. Okay. Scenario 1. Now, in the first scenario, what happened? Okay. So, zookeeper failover controller has sent heartbeat of name node 1 to zookeeper 1. Okay. At 7:45. Okay. At the same time, it has sent to zookeeper 2 also. Okay. So, okay. See, name node 1 heartbeat has come to zookeeper 1 first, and zookeeper 2 also first. Okay. Then okay, name node 2 heartbeat has come at okay. Okay. Yes or no? Yes.
Yes, sir.
Okay. Now in this scenario, okay, how many? Okay, so whom okay, zookeeper 1 is okay. As per zookeeper 1, who is active? Who should become active?
Name node 1.
One.
Yes, sir,
One
yes,
name
okay.
node 1.
So zookeeper 1 is voting to zookeeper. Zookeeper 1 is voting to name node 1. Okay. So zookeeper 2 is voting to as per zookeeper 2.
One only. Name node 1.
Name node 1 only. Okay. It means okay. So zookeeper 1, both the zookeepers are electing name node 1 only. It means okay. Name node 1 has got how many votes? In this scenario, name node 1, okay, 2 zookeepers, okay, 2 zookeepers are saying, okay, name node 1 should become active, okay. For name node 2, how many zookeepers are saying? 0 zookeepers. Yes or no? Who is supporting the name node 1? Both the zookeepers, correct?
Yes, sir.
Okay, name node 2? So supporting means, okay, as per zookeeper 1, okay. So what zookeeper 1 is telling, okay, as per my data, name node 1 should become active. It means, okay, so zookeeper 1 vote is for name node 1, correct? Huh?
Yes, sir.
So here, so zookeeper vote is zookeeper 1. In this scenario, so zookeeper 1 vote will be for name node 1. Okay. So zookeeper 2 vote in this scenario, name node 1 only. Okay. So name node 1 has got 2 votes. Okay. And name, okay. And name node 2. Name node 2 has got 0 votes. So no. Okay. So okay, the condition is that whoever get more votes, that day will become active. In this scenario, who will become active? In this scenario, who got more votes?
Name node 1.
Name node 1, sir.
Name node 1 will become active, and this will be in standby mode. Understood? This is scenario 1. Okay. Any questions in this scenario?
No, sir. No, sir.
I will show you scenario 2. Okay. So let's say, okay. So both the failover controls are started. Okay. So name node has, okay, failover controller 1 has a heartbeat of name node 1 to zookeeper 1 at 7:45. Okay. 4 a.m. Okay. These are sent at 3 a.m. Now tell me, okay. So ZK1 zookeeper 1 vote will be for whom?
Name node 2.
Name node 2.
Name node 2. Zookeeper 2 vote?
Name node 2.
Huh? Name node
2.
Who came first to zookeeper 2? What of these two?
1,
1 or 2?
1, sir.
1. This is
2,
4
sir.
seconds.
2, sir. Name node 2, sir.
Name node 2. Okay. So as per ZK2 vote also for name node 2. Okay. So name node 1 has got 0 votes. Okay. And name node 2 has got 1 vote. Sorry, 2 votes.
2.
Now in this scenario, who will become active and who will become standby?
Name node 2 is active.
Name node 2 is active.
And name node 1 will be in standby. Okay. Okay, say here with the help of the zookeeper, so I'm trying, okay, I'm trying to decide the correct name node as active. Correct name node is named as standby. Okay, understand? Okay. Now let us take the third scenario. Scenario 3. Okay. So now, okay, zookeeper 1. Now you see, sir, what is the third scenario? Okay. So failover controller 1 has sent heartbeat of name node 1 at 7:4. Okay. But okay, to this one at 7:3. Okay. And failover controller has sent heartbeat to zookeeper 1 at 7:45. But here it is 7:4. Okay. As per zookeeper 1, what is the to whom zookeeper 1 will vote? Out of these two?
Name node 2.
Name node 2.
Name node 2. Okay. In this scenario, to whom okay, zookeeper 2 will vote?
Name node 1.
Name node 1. Okay. So name node 1 has got how many votes?
1, 1.
1 vote. Name node 2 has got
1.
1 vote.
so this is a valid scenario. Is it a valid scenario now? Now there is a tie. Okay, not a valid scenario. What is tie here?
1-1. They both
One,
got
one.
That's the same number of.
So name node 1 has got 1 vote, name node 2 has got 1 vote. Okay, it means okay, both have got same votes. Okay, it means it is a tie situation. It's not a valid one. Okay, when there is a tie situation, okay, they cannot take a decision. Understand, sir? So it means okay, both will be in standby only. When there is a tie situation, they cannot take a decision. Both will be in a standby mode only. Then what is the use of okay having two zookeepers here, guys? Huh?
Only when one zookeeper is down.
Sorry?
Like because if the zookeeper is down.
Okay. See, we thought to say earlier okay, we had only one zookeeper, and if that one zookeeper is down, okay, we don't have any person to change the status from active to standby. Correct or not? Okay. So, but okay, we got one more zookeeper in the place for high availability. But okay, what is happening? What is happening? Okay, they are entering into a tie scenario. Okay, see, if they enter into this scenario, that's fine. If they enter into this scenario, that's also fine. But they enter into this scenario, which is a problematic scenario, not a valid scenario. Not a valid scenario. Yes or no? What to do?
Yes.
What to do? Suppose okay, by mistake, okay, if third scenario occurs, okay, both name nodes will be in standby only. Then what is the point of okay, having zookeepers? Sir, we are bringing more and more services or more and more people because to solve the issue, not to increase the issue. Yes or no? Yes or no, guys?
Yes, sir. Yes, yes.
Okay. So in this scenario, because of two zookeepers, okay, sometimes okay, issue is getting solved, but sometimes okay, issue is becoming worst. What to do now? What to do?
Get one more zookeeper maybe.
Get one more
zookeeper.
Huh? Okay. So now I'll bring one more zookeeper now. I'll bring one more zookeeper here. Zookeeper 3. Okay. Why I'm getting okay zookeeper 3 here, guys? Earlier, okay, we had two zookeepers. No. Two zookeepers. Okay. So voting mechanism is happening how? Okay. N1 and N2. Okay. Either okay. So both the zookeepers are. This is the situation actually. Okay. ZK1, ZK2. ZK2. Okay. This is the situation. Okay. So ZK1 may say 1-1. Okay. This is fine. Okay. In this scenario, sorry, ZK1 is saying okay. ZK1 and ZK2. Okay. There are two people. Okay. First scenario, so okay, 2 votes are here, 1 vote, 0 votes are here. Okay. Okay, 0 votes are here, 2 votes are here. Okay. So 1 vote here, 1 vote here. Okay. This is okay. This is valid. Valid. Okay. Valid.
Sir, I have a question on invalid scenario actually.
Yes, sir.
So, like you said, like it has got same number of votes. So, zookeeper will not decide which one should be active.
Yes, sir.
Will it wait for another heartbeat so that?
Let's say even another heartbeat also like that only.
Okay.
Yeah, so let's say,
sir, you said right, sir. I mean, if it's very in milliseconds or something, so based on that, it can decide, no, sir.
Even that also same, sir. Think that. Think that. Think in that way. Okay. Even that is also same.
Sir, in that 2 zookeeper case, they can't talk each other, na? How it will decide who is inactive, who is in standby?
2 zookeepers, huh?
Yes,
so
sir.
now,
Yes,
okay,
sir.
so when you have zookeepers,
Zookeepers can't talk each other.
No. Okay, so when they have multiple zookeepers, they work like a single unit.
Okay.
Understood? They work like a single unit.
Then one should be standby and one should be inactive.
One should be
standby, one should be inactive.
Where?
Zookeepers.
Who will make zookeeper 1 as active and who will make zookeeper 2 is standby? Will you bring one more zookeeper to decide who should be active and who should be active zookeeper and who should be standby zookeeper? Huh? Tell me.
So the voting mechanism, who will take care and all, sir? Then final decision is taken by?
Sorry?
The voting mechanism, for understanding purpose, you told, or this mechanism?
No. It's a mechanism, sir. Inside Hadoop, okay. So inside zookeeper, this is what happens. I didn't explain, just for this.
Okay.
Understand?
That means my doubt is who will take care and all final decision. These many votes have.
Okay.
Like
I'll tell you, sir. Okay. So
only both. Sir.
Okay. This is what is happening, sir. This is what is happening currently. Yes or no? With the 2 zookeepers. Okay. So this is what is happening. With the 2 zookeepers. Okay. This is what is happening. Okay. So now, okay. So let us see this one. Okay. With 3 zookeepers, what can be the scenario, sir? ZK1, ZK2, and ZK3. Now I have 3 zookeepers. Okay. Now tell me what will be the votes. All 3 can make name node 1 is active. If all 3 saying name node 1 active, name node 2 will get the votes. Yes or no? Okay.
Yes.
But out of these 2 zookeepers are saying this one zookeeper is voting to name node 2. Okay. Yes or no? Okay.
Yes,
in this scenario, who will become active?
1.
2, 1, yes.
Name node 1.
Okay. In this scenario, who will become active?
2,
Name node 1.
Name node 1.
1.
Okay. This is also valid scenario. Okay. And third scenario. Okay. So 1.
Name node 2.
Name node 2.
Also valid scenario.
Yes, sir.
Okay. So now, what is the other scenario? Now tell me, who will become active out of in this scenario?
So name node 2.
Name node
Name node 2, sir.
Name node 2 will become. Okay. It means if I go with 2 here. Okay. It means even number. Even number. Okay. Odd number. Even number. Even number of zookeepers and odd number of zookeepers. So now, with odd numbers, all are valid scenarios. Correct?
Yes, sir.
Okay. Now, we'll go one more. Okay. With 4 zookeepers.
Again, there can be a chance of problem. Again, there is a chance to fight.
4-0. Okay. 3-1. Okay. 2-2. Okay. 1-3. 0. 4. Okay. So this is valid. Okay. This is also valid. So this is invalid. Okay. This is valid. This is valid. Okay. See, when you have 4 zookeepers, again, we are coming up with some invalid case. Yes or no? Even number. Again, okay. I'll go with 5 zookeepers. In this scenario,
Hello.
5.
Sir.
Answer.
Sir, what if one of the zookeeper will down and the other two?
I'll come to that scenario also, sir. Okay. So with the 5 zookeepers now, how it is working? Okay, 0. All 5 votes can go here. 0. Okay. Okay. 4 1. Okay. Then 3 2. Okay. Then 2 3. Then 1 4. Now you see all are valid scenarios, right?
Yes, sir.
Okay. So this is invalid scenario. Okay.
Sir, with 5 zookeepers, it is odd number.
Odd number, yeah.
You have written even.
Okay. So now, wherever you have even number of zookeepers, we are encountering with a tie scenario, which is an invalid scenario. Correct or not? Okay. So that is the reason always better to go with the odd number of zookeepers or even number of zookeepers.
Odd number of zookeepers.
Odd number of zookeepers. Okay. So at any point of time, we should go with the odd number of zookeepers. Okay. So even okay, so if you have once in okay, so we will take once okay with one zookeeper. One zookeeper. So here okay, you have okay, name node 1, name node 2. So you have ZK1. Okay. Okay. Only one zookeeper, right? ZK1. Okay. So what will the voting scenarios here? What will the voting scenarios? It may be so it may get 1 vote, 0 vote, or 0 vote, 1 vote. Any other chances?
No.
No, right? Okay, we have only one zookeeper. This one zookeeper, okay, either vote this one or vote this one. Okay, no other chances. Okay, and both are valid scenarios. Okay, so now if you see wherever I have odd number of zookeepers, okay, everything is valid. Yes or no? But wherever I see even number of zookeepers, okay, here you are ending up with a invalid state actually. Okay, it's invalid means tie scenario. Okay, tie scenario. Okay, so now tell me, going with odd number is better or even number is better?
Odd number is better.
Odd number is better. Okay, so good. Okay, now I'm going with odd number. 3 numbers. Okay, I'm going with 3. Okay, so now tell me, okay, will this failover controller send heartbeat to all 3 zookeepers or not?
Yes, sir.
Huh? Obviously, the failover control will send heartbeat to all 3. Okay, so this failover control will send heartbeat to these 3, and this failover control will also sending heartbeat to these 3. Correct or not? Okay, so now, okay, anyway, we have taken 3 zookeepers. So now voting will be like, okay, this part, voting will be like, okay, so this is the part with the 3 zookeepers, right? So this is the one. So we are with 3 zookeepers. Okay, the voting will go like this. Okay, either all 3 votes will come here, or okay, 2 votes. Okay, 3-0 or 2-1 or 1-2 or 0-3. Okay, but in any scenario we have valid scenario. Okay, no tie at all. Understand? Okay, so if all are working fine, understand guys, if all are working fine, okay, then no issues at all. This is working fine. Okay, this is also working fine. This is also working fine. Okay, because okay, so you have set up 3 zookeepers, right? Okay, If all three are working fine, no issues at all. Will you agree with me? Huh?
Yes, sir.
Okay. So now, see, you set up okay, 3 zookeepers, okay, but unfortunately, one zookeeper is down here. No, sir. What will happen now? Now, do you have 3 zookeepers to take a decision? Huh?
Only 2.
Only 2.
Only 2. Okay, again, okay, only 2 means, okay, again, there is this kind of
Invalid case.
Yes or no? Invalid cases. Okay. So now, but actually, okay, see, I started with 3 zookeepers, but unfortunately, 1 is down. Yes or no? Okay. So in this scenario, again, okay, if you have 2 zookeepers, okay, again, there is a tie scenario. There may be some invalid case. Okay. How to overcome this one? One thing is that, okay, if I restart, okay, failed zookeeper immediately, problem will be solved. Correct or not? Huh? Problem will be solved. Okay. But okay, let's say restarting zookeeper 2 is taking some time. In that scenario, there are high chances that the tie scenario may come, right? Yes or no, guys? Yes or no? Okay. So now, see, I have put 3, okay, but unfortunately 1 is down. Okay. So until I bring it back, bring this failed zookeeper back. Okay. So my show should run with other 2. Will you agree with me or not? Okay. So that is the reason of what they have done. Okay. They introduced a concept of leader follower. Okay. So here they introduced the concept of leader follower of zookeepers. Okay. This is the concept that they got. Leader and follower among zookeepers. Okay. So this is the concept that they thought. Okay, they got otherwise. Okay. So now the idea is that see, normally these 3 are working like a single unit. Yes or no? All are working together, right? Yes or no, guys? Are they working together or not? They are working together. Okay. Yes. So now, when they are working together, before they receive heartbeat from failover controllers, before failover controllers start sending heartbeat, when you start these 3 zookeepers, these 3 will talk internally and decide one person as leader. Understand, guys? Huh? So now I have 3 zookeepers, who should become leader and who should become follower in that?
So, sir, in that case, that scenario also can be addressed, right?
Right, can be measured by time, right? Whichever zookeeper started first, that will be the leader zookeeper.
Sir, one question here.
Yes, sir.
Sir, in that case, the scenario of even number will also can be addressed, right? If there is a one leader, then only one can be.
Yes, sir. Yes, sir. Okay. So to avoid this one, guys, see, when we directly go with odd number of zookeepers, we are facing some invalid scenarios. To overcome this one, we are going with 3 zookeepers. We have gone with 3 zookeepers. If all 3 zookeepers are up and running, fine. Then fine, no issues at all. But what in case if one out of 3 zookeepers, 2 are running and 1 is down, then we are entering into a situation of even number of live zookeepers. Correct or not?
Yes, sir.
Correct or not? So to overcome this issue, so here, what the zookeepers are doing? So zookeepers are going for an internal election first. So zookeeper, okay, so are going with the internal election between zookeepers. Okay. How this internal election will happen? Okay. So now once all zookeepers are started, okay, they will compare. Okay. So whatever the start time, okay. So now zookeeper 1, okay, zookeeper 1 started at 7, okay, 8, 11, okay, 0, 1. Okay. Zookeeper 2 has started at 8, 11, 0, 2. Zookeeper 3 has started at 0, 3. Now tell me, okay, out of these 3, which zookeeper will become active? Leader?
1.
Obviously,
1 is
leader. In this scenario, leader. Okay. Now, okay. Now, due to some reason, leader is down. Leader is down. What will happen? Now I have
second one is the leader.
Okay. In those 2 zookeepers, who will become leader?
Second one is.
Second one will become leader. Yes or no? Yes or no, guys?
Yeah, yes, sir. Second one is the leader.
Second one will become the leader. Okay. So it means, okay, whoever is alive, okay, for those live zookeepers, okay, it will check. Okay. So who has the least start time, that will become the leader. Okay. So think that in this example, okay, this is the leader, and okay, this is okay follower, and this is follower. Okay. Now tell me, okay. Now tell me, okay. One follower is down here. One follower zookeeper is down. Okay, now I have one leader zookeeper, one follower zookeeper. Okay. When there is a tie scenario, okay, we are coming up with a solution for the tie scenario. Okay. When there is a tie scenario, okay, whichever name node selected by leader zookeeper, okay. Okay. When there is a tie scenario, leader vote will be like 1.5 vote. It is not 1 vote. Leader vote will have always weightage. Okay. When there's a tie scenario, to whomever leader zookeeper will select, okay, that they will become active. Understood?
Yes, sir. We'll follow the leader.
Just follow the leader rule actually. So when there's a tie scenario, to whomever leader selects, okay, that guy will become active. Understood?
Yes.
Understood or not? So okay, if there is no, okay, so if all 3 zookeepers are up and running, okay, then okay, whomever leader selects, that will become active. No, right?
Sir.
Only in even number of scenarios. Only in even number of scenarios. Okay. When you have even live zookeepers, only in that scenario, okay, later vote will have some priority. Okay. Otherwise, okay, later vote will not become. Okay. So later zookeeper vote will have priority. Only when we have okay, even number of live zookeepers. Understood? Okay. So will not have any priority. Will not have any priority. Okay. When we have odd number of zookeepers, live zookeepers. Understood, sir? See, later vote will be given priority. Okay, when you have okay even number of live zookeepers. In this scenario, okay, if 1 is down means okay, I have two zookeepers. Okay, 2 live zookeepers. It means okay, even number of live zookeepers. Okay, so when you have even number of live zookeepers, okay, so whoever later selects, okay, that they will become active. Got it? Got it? Or any questions?
Sir, in real-time situation, for example, N1 is name node 1 is name node 1 will be active.
Okay.
When it is going on, suddenly what is leader zookeeper? Okay, the first one is down.
Sir, okay, see, okay. When okay, status will be okay. When status changes will come into picture.
only when we restart the cluster.
Okay. See, status changes will come into picture. When you start, okay. Name node or name nodes, okay. We'll come to picture when, okay, when you restart name nodes, or when active NN is down. Okay. Only this is scenario, status change is required. Okay. Suppose okay, now, okay, these three together, okay, they have selected, okay, this is active, sir. Active, this is standby. Standby. Okay. After selecting active standby, okay, okay, all three zookeepers are down. All three zookeepers are down. What will happen now?
No bother even.
Is there a problem to Hadoop cluster?
No, sir.
No.
A problem to name
One node is
node.
active, it will go with active.
And it will continue. So whoever is active, okay, they will continue. So when the problem comes, if active is down, if active is down, if active name is down, then only I require zookeeper. When I need zookeeper help, guys, tell me, very simple. When I need zookeeper help,
when both are
in standby, I need zookeeper help. Yes or no? Okay. Yes. If active name node is down, okay, one is active, one is standby. If active is down, I need zookeeper help. Yes or no? Yes or no? In remaining scenarios, okay, do you think okay we require zookeeper help? Why are we bringing zookeeper, sir? To decide the name node state. Okay, name node state is already decided. After deciding the name node state, okay, do we require these zookeepers?
Yeah, got it, sir. Got it.
Yeah. Okay.
Sir, I have a doubt.
Yes, sir.
Sir, what if three zookeepers will start at the same time and suddenly one of the zookeeper is going to fail? How to decide who is leader, who is follower?
Okay. So when three zookeepers are starting, okay, so there are chances that okay. See, starting is different. Starting is one-time activity. Sending heartbeat is different. Sending heartbeat can be every 3 seconds, right? Yes or no, sir?
Yeah, yes, sir. Yes, sir.
Okay. So one-time activity. Starting is one-time activity. Okay. So definitely when you are starting, okay, when you are starting, there may be chance that okay, milliseconds or microseconds or nanoseconds difference.
Okay, sir.
Got it. But for heartbeat, okay, there may be change.
Okay.
Okay, heartbeat is a continuous process, right?
Yes, sir. Yes.
Okay, in that scenario. Okay. So, guys, okay, here we require zookeeper only when there is when both the names are standby or if active name is done. Only in this scenario. Rest of the scenarios, okay, do we require zookeepers?
No.
No, sir. No.
Okay. So now, okay. So I hope you understood the concept of zookeeper, sir. I will show you.
Yes, sir. Yes.
Okay, I'll show you practically. Okay. First, okay, let us see the theory part of zookeeper. Zookeeper is a highly available, highly reliable fault-tolerant coordination service for distributed application. Okay.
So fault-tolerant
means okay. So issue solved. Fault-tolerant means okay. It can solve the issue automatically. It is doing the same thing, right?
Yeah, yes, sir. Yeah.
Okay. So now here, okay, so we need to remember few technical terms. Okay, the first one is ensemble. Okay. Ensemble means okay. So here a group of zookeepers that act like a single unit. Okay. So that is called as an ensemble. Okay. Now in this scenario, how many zookeepers are participating in this group? How many zookeepers are participating in this group?
3.
Huh?
3.
3 zookeepers. Okay. 3 zookeepers. Okay. 3 zookeepers. Okay. So now, okay, I will say ensemble equal to 3. Right. I will say ensemble equal to 3. Okay. But okay, here, okay. What is quorum? quorum should be like, okay, quorum is like, okay, how many zookeepers should be up and running in the ensemble to take a decision? Understand, guys? To take a decision, how many zookeepers should be up and running? Okay. So normally, sir, okay, when you are taking a decision, okay, you have, okay, let us take this scenario, sir. Okay, you are a manager, okay, and under you, you have 10 people, sir. Okay, let's say there is some budget to go to dinner. Okay, so now manager is asking, okay, hey guys, okay, we have, okay, some budget, okay, 20,000 rupees budget for dinner. Okay, you decide, okay, which hotel we can go for dinner. Okay, understand, guys? You decide, okay, which hotel we can go for dinner. Okay, now, if, okay, now, okay, I have all 10 people. Okay, now each person will go to one hotel. Yes or no? Yes or no? Yes. So now, after taking all people's vote, all people vote. Okay, now I will see. Okay, fine. Okay, how many are voting for hotel A? How many are voting for hotel B? How many are voting for hotel C? Okay, so now I will take. Okay, so whichever hotel majority people selected. Okay, I will take my team to my team there for dinner. Yes or no? Sir, okay, very simple, sir. Okay, see, if we think our Hadoop examples, okay, in human life, if we correlate Hadoop examples with human life example, it will be easy for me to remember. Okay, sir. So Venkata is a manager. Now he has a team members. Okay? So team members. Yes, 10 team members. Okay, there are two hotels, guys. Okay, hotel 1. Hotel 2. Okay. So now, okay, now how will I select? Okay, if which hotel should go today? I'll ask, okay, all my 10 team members, guys. Okay, you select. Okay, so okay, fine. Okay, first team member 1. Okay, you tell me what is your preference. So team member 1 is saying that I prefer hotel 1. Team member 2, I prefer hotel 2. Team member 3, I prefer hotel 2. Team member 4, I prefer hotel 2. Team member 5, okay, I prefer hotel 1. Okay, so like this, okay, I will collect the voting from all the 10 people, 10 team members. Yes or no? Yes or no? Okay, finally I'll decide, okay, out of 10 team members, okay, 6 members are saying hotel 2, okay, and 4 members are saying hotel 1. Okay. Now tell me where we will go.
Hotel 2, sir.
Okay. Another scenario, okay, out of 10, okay, so 6 members are saying of hotel 1. Now in this scenario, where you will go?
Hotel 1, sir.
Okay, hotel 1. Okay, but let's say out of 10 people, let's say, okay, 8 people came to office today, but 2 people did not come. Okay? They are not participating in the election. Yes or no? Now can I take a decision, guys? See, out of 10 people, okay, so 8 people only in office. Okay, 2 people did not come. Okay, now I need to take a decision. Okay, what I can do? Again, okay, the same thing I'll ask, okay, hey, I'll ask, okay, all the 8 members, guys, okay, give me your voting. Anyway, majority people are here, right? So I can take a decision. Yes or no? Okay, now, okay, so out of 10, only six people came to office. If 6 people, can I go for voting? Majority are there. Okay, but what in case if I have only 2 people in the team in office today? Okay, can I take decision of these 2 people and okay, take a final decision? Can you take a decision with less people?
No,
sir.
No, right?
Minimum number of people.
So it means, okay, whenever you are taking a decision, Okay, in your team, okay, majority people should be present. Then only you can take a decision. Yes or no? Sir, okay. Suppose, okay, let's say there is a decision taken is taken by CM. Okay, only CM and one MLA will decide, or okay, CM and majority of the MLAs will sit together and okay, discuss and decide.
Majority of MLAs.
Majority of the ministers and okay, CM okay will sit together and decide. Correct or not? Okay, so that's the majority. Okay, that's where okay you will come as majority here. Okay, so ensemble means total people in the group. Okay, but quorum. What is quorum? Okay, majority of. Okay, tell me out of 3 zookeepers. Okay, what is the majority?
3.
Huh?
3.
3 ensemble.
3, 0 or 2, 1.
No, sir. Okay, out of 3. Okay. Okay, what is the majority here? Suppose okay,
At least 2.
2. At least 2.
At least 2 people should be present okay, to take a decision. Yes or no? Suppose
Yes,
okay,
sir.
if out of 3 zookeepers, okay, 2 zookeepers are down, can I take a decision with okay, 1 zookeeper? Understood, guys?
Yes.
Okay. If I have 3 zookeepers, okay, 1 zookeeper is down, okay, you still have 2 zookeepers. It means majority zookeepers are there. Okay, so you can take a decision. You can take a decision. Okay, but out of 3 zookeepers, okay, if 2 zookeepers are down, you cannot take a decision because okay, you don't have majority. Okay, now tell me, if I have only 1 zookeeper, what is the majority? 1. If I have 2 zookeepers, what is the majority?
2.
If I have 1, that is like 50%, right? Yes or no? So majority is 2. All 2 should be there. Okay. So if I have 3 zookeepers, now tell me.
2.
Huh?
2.
2. Okay. If I have 4 zookeepers.
3. 3. 3.
It should be there. Okay. If I have 5 zookeepers.
3. 3.
Okay. See, if 3 are there means okay. Out of 5, 3 are there means okay. 60% strength is there. The strength should be more than 50%. More than 50%. Okay. It should not be equal to 50% also. It should be more than 50%. Understand? More than 50 means 50 to 100, 51 to 100. The strength should be 51% to 100%. Okay. So here quorum means okay. So what is the majority of the zookeeper should be running in the ensemble? Quorum will decide what are the majority of the zookeeper should be up and running in the ensemble. Got it? Okay. So now how you decide? Okay. So how you decide okay, in the ensemble how many nodes that should be up and running? Okay. There's a calculation here. Okay? Even if you go with this calculation, so you get the same numbers. Okay. Well, what is G node? What is G node here? When I say G node is okay. So what? Okay, we understood that. Okay, we understood that.
Sir, how is the above formula can be used, sir, for calculation purpose? Sir, above formula how can be used for calculation that how many nodes will be up? You have given on formula, right, sir? Sir, how can we use that?
Okay, so okay, let me put this formula here. Okay. 1 zookeeper, 2, 3, 4, 5 zookeepers. Okay. So here, okay, the formula is that. Okay, what is the formula here? Okay. Okay. This minus. Okay. Round off this by 2, comma 0, 0, minus 1. Now you see. Is the send out of 5K, how many should be up and running? Out of 6. If I have 8 zookeepers, okay, 6 is the majority. Understood? If you have 8 zookeepers, this is the majority. If you have 7 zookeepers, 4. Okay, if I have 6, 6 means 4. 4 should be up and running. If 3 are up and running, it is 50%. Okay. So I told that okay, availability should be more than 50%, not equivalent to 50%. So more than 50%, at least okay, 4 should be up and running. Okay. That is quorum. Okay. Now, what is a G node? What is the G node? Okay. So here, guys, okay, we discussed like okay, whenever failover controller will send a heartbeat to zookeeper. Okay. So each zookeeper is recording a time, right? Huh? Recording at okay, recording with the name node 1 heartbeat, okay, name node 2 heartbeat. Yes or no? So now, based on the time, they'll give a token number. They'll give a token number. They'll give a token number. Okay, what do you mean of token number? Sir, okay, so let us take this scenario. Okay, let's say there are 2 people who entered in the bank. There are 2 people who entered in the bank. Whom should we serve first? Whom you will serve first?
Whoever entered first.
Whoever entered first. Okay. So now, how do you say that? Okay, what is the proof for? Okay, so let's say person was telling I entered okay inside the bank by sharp 10. Other person also telling okay sharp 10. How will you decide now? What is the easy mechanism to remember? Okay, token. Okay. So I will tell okay the people okay guys if whoever come first go and take the token based on the token number I'll decide yes or no. Okay, it means okay whenever people come inside okay so bank will give the token number first okay based on the token number okay you will understand okay who came first and to whom we need to serve first. Correct or not? Here also it is the same case. Okay. So whenever a failover controller send a heartbeat of okay name node 1 immediately zookeeper 1 will give a token number. Okay, token number for name node 1. Okay, the same way zookeeper 1 will give token number for name node 2. Zookeeper 2 will give a token number for name node 1. Zookeeper 2 will give a token number for name node 2. Understood?
So, sir, token will be distributed on the basis of timings that had been arrived.
Yes, okay, yes, okay. So who will distribute these tokens? Zookeeper will distribute these tokens. Okay, on what basis? Whoever comes first. Got it? Okay, so that is called as a G node. When I say G node, okay, it is a token number. Okay, so zookeeper will allocate one token number to each and every client connected to it, and okay, so that token number is called as a G node. Understood? So based on okay your arrival, based on failover controller 1 arrival. Okay, zookeeper will give a token number. Based on failover controller 2 arrival, zookeeper will give a token number. Understand? Understand, guys? Okay. Based on these token numbers, they will decide. Okay, so who came to me first and who came to me late. Got it? Okay. So that is G node. Okay. So now there are types of G nodes, guys. There are persistent G node and okay and ephemeral G node. What is persistent G node here? When I say persistent G node, okay, it is kind of a fixed G node. Okay, your token number is always 1 only. Is it possible, sir? Huh? Understand? Okay, so persistent token means okay. So let us take this scenario, guys. Okay, let us take this scenario. Let's say this is the bank. It's a bank. Okay. Bank. Okay. So person 1 came inside. Okay. He has taken token 1. Okay. Yes or no? Person 1 came inside first. Okay. And he has taken token 1. Person 2 came inside and he has taken token 2. Okay. Now, okay. Now, so this okay, came at okay 9:45. Okay. And he has taken token 2, token 1. Okay. He came at okay 9:50. And okay, he has taken token 2. Yes or no? Person 1 came at 9:45 and he has taken token 1. Person 2 came at 9:50. Okay. And okay, yeah, okay, he has taken token 2. Okay. Now, okay, bank will start by 10 o'clock. AM. Okay. Now 10 AM. Okay. So now time is okay 9:59 AM, sir. 9:59 AM. Okay. Person 1 went outside. Okay. Person 1 went outside. Okay. Now 10 o'clock they started, and okay, first whom they will call? Token number 1. Is he there?
No, sir.
No, sir.
So, token number 1. Okay, is he there?
No, sir. He's outside.
Not inside bank. Not in the bank. Yes or no? So ignore. Okay. Then called token number 2. Okay. So provide the service. Yes or no? So see, now even though this guy has got token number 1, okay, this token is valid until he is inside the bank. He has taken token number 1, he went outside. Okay. So now he came back at 10 okay, so 10:30. That time if you show okay, my number is token 1, okay, what they will say? No, sir. Okay, so I already called token number 1. You didn't turn up. Okay, I guess okay, you were not in the bank. So now okay, now you cannot show the token number 1. Okay, go and get the new token. That's what they will say, right? Yes or no, sir?
Yes, sir.
Yes.
Okay. So, but what in case okay? Okay, now okay, let's say this guy has okay. Now time is 10:30. 10:30. Okay. Came inside bank. Okay. Now, okay. So at 10:30, now okay, so called okay, T3, token 3, token 4. Okay. Now 10:30 AM. Okay, so T1 came inside, person 1 came inside. Okay. Now, okay. This is the case. It means okay. See, when we call this guy is not in the bank, correct or not? But okay, he came at 10:30 AM. Okay, and he showed his token number 1. He got the service. It means okay, his token is valid even after its expiry also. Correct? Yes or no, sir? See, clearly I'm telling you that okay, see what time okay, person 1 came, but okay, when he left, but when he came back, when he got served. But normally, okay, when you came back at 10:30 and show the token 1, what they will say normally?
Wait, sir, the service is finished.
Sir, okay. So you go and get the new token. So token 1 is already called. Okay, token 1 is gone. We will not consider token 1 now. Okay, we already called, that time you were not there. So, okay, discard this token 1 and go and take the new token. Yes or no? Okay. So if this is the type, okay, this is called as a persistent. Okay. Okay. The same example I'll give here. Okay. So you came back at P1, okay. So show token 1, okay, invalid ticket. Okay. So when you show, okay, T1, okay, what they are saying? Go and take a new token. This is called as a ephemeral. Gnode is nothing but okay token. Persistent gnode, ephemeral gnode. Okay. So persistent gnode means okay. Okay. Even your time is expired also, still okay, your token is valid. Okay. But okay, when it's ephemeral gnode, okay, when they call you, when your time is expired, okay, you cannot use this same token. Okay. You need to take a new token, and okay, the new token will be served here. Okay. Here. Okay, so then, okay, so now the person 1 is taking okay, 10, 31.
So sir, in case of, sir, one question here. Sir, in our case, if any server goes down or any node goes down, so that will be allocated a new token in ephemeral one, but in persistent one, the older token will be working, right?
Yes, sir.
It comes up.
Yes. Okay. So in case of persistent, okay, gnode, okay, older token will be still working. Okay. Understood. Okay. In the ephemeral, okay, old tokens will be expired and only new tokens will be.
So is this a configuration in the server?
Yes, sir. Okay. You need to configure this. But okay, normally what model is easy for us, guys? Persistent model is okay. You will like, okay, ephemeral model, okay, you will like in real time. I mean, okay,
Ephemeral time.
Ephemeral is better, yes.
Better, okay. See, because okay, see, some person will come and at morning 8 o'clock and he will take a token and go. Okay. And like RMC will come at 10:30 and he will come and say, hey, I've taken in the morning itself, okay, you serve me first. He's not waiting in the queue at all, right? Yes or no? Okay. So normally, okay, we don't prefer persistent gnodes. Okay, we prefer ephemeral gnodes only. Okay. So in the same way, even Zookeeper also prefer the ephemeral gnodes. Okay. Suppose okay, if okay, first okay, let us take this scenario. Okay, what is gnode here? Okay, so here, okay, let's say name node 1. Okay, so here okay, you have name node 1 failover controller 1. Okay, and okay, they are sending heartbeat to Zookeeper 1. That's it. Okay. Heartbeat to Zookeeper 1. Okay. When it's sent heartbeat to Zookeeper 1. Okay. So when the heartbeat will come here for Zookeeper 1, when the heartbeat will come. Okay. Let's say okay 7. Okay. Okay. Let's say 8:45 00 01 AM. Okay. 01 8:45 01. Okay, heartbeat came. Okay, so what is the token it has given? Token 1 it has given, let's say. Okay, so now, okay, it will be continuous checking whether this guy is there or not. Okay, then the next heartbeat will go from failover controller to Zookeeper every 3 seconds, right? Next heartbeat will get 8:45 4 after 3 seconds. Okay, now token 1 only. Okay, again, okay, next heartbeat will get token 7. Okay. Heartbeat sent. Okay. Token 1. Heartbeat sent. Heartbeat sent. Okay. Heartbeat missed. Did not send. Okay. Heartbeat sent. Okay. Normally it should send heartbeat at okay. So 8, 9, 10, right? Okay. But it is sent at 11, 12, 13. Okay. Then what will happen? Understood this? Even one heartbeat is missed, okay, your token is expired. Understood? Or any questions? Even one heartbeat is missed, your token is expired.
And
Any
sir,
questions?
sir, one question. G nodes are being used for quorum purpose, right? Just to
No,
decide.
no. G nodes are the ones. Okay, so G nodes or tokens are used to decide who came first, who came second.
Okay. Okay, sir.
Okay. Sir,
Z
okay, sir.
node is a service in Zookeeper, or what is it exactly?
What, sir? Can you come back? Can you come back? What is your question?
Z node is a service inside
No, G
Zookeeper
node is a
service.
token number, sir. Okay, so here, okay, so G node 1. Is it fine now?
Okay, sir. Yeah, got it.
Is it fine now?
And sir, who came first is required only to select the leader, right, sir?
Okay. Okay. So now, okay. Okay, I'll tell you. Okay. Name node heartbeat. Name node 1 heartbeat sent. Okay, 845. Okay. What are the token given to name node 1? Token 1. Yes or no? Huh? Yes or no, guys? Okay.
Yes, sir.
Okay. I'll put it here. So now. So wait. Parallelly, this is about name node 1, right? Here, okay, I have parallelly name node 2 also. Huh? 2 AM. Okay. So for name node 2, what is the token it will give? What is the token number given to name node 2?
Token number 2.
Okay. Now, okay. So now, okay. So here, okay, at this stage, okay, who has the least token number? This is 1. Name node 1 is 1. Name node 2 is 2. Okay. So name node 1 is active. Okay. Now, okay, next heartbeat will come at 8.4. Okay. So this heartbeat will come at 8.5. Okay. Now, what is the token number for this one and what is the token number for this one? Same token number. Okay. So now, okay. So N1 heartbeat sent. Okay. So 7 AM. Okay. So this is the same token number. Okay. This is 8 AM. This is the same token number. Okay. Now NN1 heartbeat is missed, sir. Okay. Then what happened? Token 1 is expired. Okay. Okay. But NN2 heartbeat is sent. Okay. Now this will retain the same token. Okay. Now, okay. In this scenario, okay. When NN1 sent heartbeat, okay, what is the G node it will get?
Token number 2.
3.
3.
No, 1 is here, 2 is given here. Now 3. Okay. So now, okay. So here, okay, this one. Okay. Now tell me, okay, till this stage, okay, whose token number is first? So till this stage, okay, name NN1 is active. Understood? Understood, sir. In this stage, okay, who has least token number? Token number 1, token number 2. Who is active now?
Token number 1, sir.
Token number 1. So it means token whose number is token number 1? Name node 1. Okay. In this scenario, who has least token, first token?
Name node 1, sir.
So NN1 is active. Okay. In this scenario,
Name node 1.
Name node 1.
Name node 1.
Name node
Okay.
1.
In this scenario, do I have first token?
2, sir.
I don't have first token.
No first, no,
I don't have first token. I have only remaining one token. Who is that?
Name node 2, sir.
Name node 2. Okay. So here, name node 2 is active. Okay. Now in this scenario, okay, who has the least token number?
Name node 2, sir.
Because okay, so when this is started, again it has got node 3. Token number 3. Understood, sir? So here, based on the token number, it will decide who should be active and who should be standby. Okay. So here, okay, no heartbeat, token is expired. Yes or no? When token is expired, okay, in the remaining tokens, it will check okay, who is the latest one. In the remaining token, okay, remaining token, I have only one token. Obviously, this will become active. Understood? Or any questions? Understood, sir. Okay. Suppose now, okay, till NN2 is active now. Okay, so okay, sir. Okay, now, okay, in the next heartbeat, okay, this is fine. Heartbeat is missed. Okay, then what will happen? This is expired. Yes or no? When it is expired, okay, then okay, which one will become active? At this stage, NN1 will become active. Okay. Now, okay. Now it started sending the heartbeat. Okay. Now what is the token number it will get now?
Token number 4.
Token number 4. Okay. So NN1. Understood, sir? Understood? Any questions? Tell me. Understood or any questions? When the heartbeat missed, token will be expired. Immediately, the next list token will become active. This is how active standby named election will happen. Okay. Guys, okay, see, whatever the class I'm explaining, okay, you will not see this information in any of the videos in internet or okay, online, any of the documents. Okay. If you listen my classes, you will understand. Okay. Otherwise, no. Okay. You cannot refer all these things. Okay. Nobody has given this much internal in detail explanation anywhere in any YouTube channel or any document also. Got it? Okay. The entire Zookeeper. Okay. So if you see entire Zookeeper, this one. Zookeeper. Okay. So Zookeeper documentation, if you take, okay, this is the entire Zookeeper, one page Zookeeper documentation. Understood? Understood, guys? Okay. Hardly you will click, okay, overview. Okay. So, okay. How many pages we have? Got it? So please concentrate, okay, on Zookeeper part. Okay. This is very, very important. Okay. Because okay, Zookeeper will be used in many other places also. Okay. So Okay, so we'll do one thing. We'll stop it here, guys, and we'll see the practicals tomorrow morning. Any questions on the Zookeeper part? How it works and all?
Sir, ZKFC numbers on what basis decided, sir?
Sir,
how many ZKFCs?
Okay, so okay. Each name node will be having one ZKFC.
Zookeeper case.
Okay, Vinod, I'll explain. Okay, wait. Okay, the voice is breaking. Okay, so here, okay. Guys, okay, his question is that, okay, how we can decide, okay, how many ZKFCs are required? Zookeeper failover controllers. Okay, so Zookeeper failover controllers are not odd numbers or even numbers. Okay, each name node will have one Zookeeper failover controller. Each name node. If you have two name nodes, two Zookeeper failover controllers. If you have only one name node, one Zookeeper failover controller. If you have 10 name nodes, you will have 10 Zookeeper failover controllers. But okay, I didn't explain a 10 name nodes concept. Okay, I am explaining 2 name node concept. Understand? Okay. So here, okay, so this is what I'm telling here. Okay, here, okay, you have persistent ephemeral. I've explained this one. And okay, Zookeeper leader election. Okay, it's like I told you that okay, internally Zookeepers will select each other, right? Internal election. Okay, so based on the time, okay, so they'll decide okay, who should be leader and who should be follower and all. Yes or no? So this is what okay, during Zookeeper leader election process, each Zookeeper in the XML say ephemeral sequential G node, token, which is nothing but token number in the election path. So the Zookeeper with the smallest token number is leader, and the remaining Zookeepers will be the followers. If leader is down, the next smallest token number will become the leader Zookeeper. Understand?
Second ఒక డౌట్ లీడర్ అండ్ ఫాలోవర్ కాన్సెప్ట్.
Yes.
యాక్చువల్ గా మనకి 3 జూకీపర్స్ ఉన్నాయి, థర్డ్ జూకీపర్ అనేది డౌన్ అయింది. సో 2 ఉన్నాయి, 1 and 2. సో
one is leader, one is follower.
యా, బట్ నేమ్ నోడ్ 1 అనేది జూకీపర్ 1 లో ఫస్ట్ వచ్చినట్టు చూపిస్తుంది. జూకీపర్ 2 లో నేమ్ నోడ్ 2 ఫస్ట్ వచ్చింది. ఐ మీన్ ఇప్పుడు నేమ్ నోడ్ 1 3 seconds కి వెళ్తే 2 seconds కి వెళ్ళింది. అప్పుడు బేస్డ్ ఆన్ వాట్ ఇట్ విల్ డిసైడ్ which one?
Based on leader vote only. To whom, okay, later Zookeeper is giving vote. Name node 1. So name node 1 will become active.
Okay.
Yeah. Okay. So yes, okay, I've explained all possible scenarios in Zookeeper. All possible scenarios in Zookeeper. Okay. Maybe I'll upload this Excel sheet, okay, in the drive to now. Okay, so please go through
excellent this. That 3x document also, please, Venkat. Yeah.
Sorry,
yesterday we updated that Python
yes,
script.
Even that also I'll upload.
Thank you.
Okay. Yeah, thank you guys, and okay, see I mean, okay, we'll see the practicals tomorrow morning. Okay, we'll start with practicals tomorrow. Okay, thank you.